Hey, so my plan for today is to implement some kind of persistent storage for the session events. But right, so we're going to start off with some tests and yeah, work from there. So I either get the choice of implementing the session or the storage first. Let's start with the storage. So we'll create our blank class, which is going to be a file system storage. And we're going to use file system rather than file because I was thinking about this and trying to work out if I should store something, store the events all in one file, or if I just do one file per aggregate, or what. Storage. And I figured that it would be easier to do one file per aggregate, because that way when we want to load a particular aggregate, we only have to load that one file rather than having to load all of the lines in another file. So if you had one file with all the aggregates, you'd have to load it and then iterate through every line, finding every line that matches the aggregate you want to load, which would involve some level of parsing. Whereas if I have the events for each aggregate in a separate file, I can just look at that one file and know everything is to do with the one aggregate. So that's what I'm going to do. Now the first thing I'm going to do before I actually shall we just write some tests? To be honest, I think actually implementing iStorage session first is probably going to make more sense. So let's rename that to session. This is the one with the interesting parts to it anyway, so. Right, so I'll implement that and get rid of those. Now if we look at our in-memory storage, so this is our reference implementation, all we know is that we'll have a new instance constructed. Potentially we'll call the open method, and then we'll return the session. So here is where we should... Well, actually, I don't think we need to do anything in particular, because we don't know what we're going to read yet. So the first thing we need to be able to do is actually read from the file system. And to do that, I'm going to use a package called file system. There we go. Oh, come back here. File system just provides a small abstraction over the actual file system. So it provides an iFile system interface with a bunch of methods for things like reading files, checking if directories exist and such. This means that we can actually fake our interaction with the file system, which helps a lot for testing. Come on, wake up. There we go. So we'll take in an iFile system. Once Rider wakes up, file system. And I think a root directory would be a good idea. Yeah, because we don't want to just store everything in the current directory or make any assumptions about where anyone wants to store data. Yeah, that'll do. So now let's go and start on some tests. We'll actually need to install that package into the test project as well. That's going. Alright, infrastructure, storage. So, oh look, we can't create CS files again. Maybe because it's synchronizing, maybe not. I'll just add a file at the bottom of this and then use refactor to create a new file. Public class file system session tests. There we go. Right. Now, we're still reloading things. Right, so our dependencies are going to be a file system. Now we can either mock the file system or we can use the in-memory file system that comes with the file system NuGet. So I'll just call it FS. Now I'm actually going to use the in-memory one because this in-memory file system actually behaves in the same way as the real file system. So throwing the right kinds of exceptions if you try and ask for paths which don't exist and that kind of thing. Whereas if you set up a fake using nsubstitute or something, you then have to actually implement all the logic for throwing directory exceptions and such. Could work. No. It's going to be one of those evenings where I just spend the whole time fighting Ryder, I think. Right. Come on, Alt Enter, thank you. Right. So, what's our first test? Well, I guess we should just start out by trying to load aggregates, trying to see if they do exist and if they don't exist. Now, the other thing to consider is we've got in-memory tests. And these really should work against the file system one as well. In fact, all of these tests should work. Session loader, how do we create one? We're manually inserting, so we need to do some manual insertion to create our storage system that is read, but for the most part, the actual tests work. And we're going to also hit into this key not found exception, which makes sense for a dictionary when you have in memory, but it's not really what you want for file system storage. So do I refactor this? Or do I just re-implement it and then refactor it later? Well, I think that one can actually come across, as should that one. So this is telling us we need builders, which we do because our file system is actually going to need to be able to build something. So session equals new file system session. Pass in the file system to that. We have a root, so let's do. I suppose technically we should do that way for the slashes. No, stuff it, I'm doing that. I prefer them. Store. Now apparently we also need builders so that we can actually build the aggregates. Now, what type are builders? That. Ah, yes, because these are provided by the actual storage class, which we haven't implemented yet. And let's add a parameter to the constructor. Nice, decided not to take the generic type definition in with it. What do we have here? Now we need an aggregate ID. That makes sense. Right, so we've got our first two tests. So we should get an exception and a different kind of exception, which we obviously won't because, well, we'll get exceptions, just not of the right type. Come on, build quicker. Excellent. Two failures. Now, we're getting not implemented exceptions because I haven't implemented anything. So let's implement stuff. When there is no builder for an aggregate type, so this is going to need this field available. So we shall say let's do this. The func of list to that. Builder. If builders try get value type of T aggregate out builder that's false. Throw new. Now what kind of exception we're expecting here? Not supported. And I suppose there is an actual message that it's supposed to give. So we'll just copy that. We're not actually asserting on the message, and as I intend to replace this with a decent exception, I shan't bother asserting on it either. And we'll leave this throwing a not implemented exception until we've gotten further with it. Right, now we want when there is no aggregate stored. So we need to construct our path that we're going to load from and see if the file exists. So var aggregate path equals path dot combine. And we'll combine our root path which I suppose would be useful if we actually wrote to a variable somewhere. Now, I think you should have two subfolders beneath things. One for aggregates, and one for projections. Because otherwise we're going to have lots and lots of files named with GUIDs and lots of files named as a projection name, which wouldn't matter too much, I suppose. Let's just do it in one directory. So this is going to be path combine aggregate ID to string. Note you should always combine your paths using path combine rather than doing string concatenation. If you use string concatenation, then you have to take into account things like which way the slashes are and whether file paths end or begin with them, and other kind of file path logic that path combine takes care of for you, such as if you do a path join for something that looks like this. Let's do, I don't know, projects slash dot dot slash projects. It'll simplify that out of the way for you, because that's the same thing. So now we shall check if the file exists. Oh, and we'll now use this variable. See if the file exists, and now we're starting to hit into async. So for the time being, I'm going to be a bad person and just fetch the results of it. So we will need to change this interface so that it is asynchronous, but I want to do one thing at a time. Although if I change the interface first, I'll only have one implementation to update and then the other one can be written. So it might be a good idea to do that first. Yeah, I'm going to keep doing this first. So if that doesn't exist, we need to throw an exception. And this time it was a key not found exception. Again, this needs to actually have a decent exception type. And as before, I shall steal the exception message off this. Right, so now if we rerun our two tests, these should now pass. There we go. Right, now if we go back to the other tests. So now we need one that checks for no events. And then we have one that does some loading. Let's do the no events one first. Now, no events in the concept of my file system just means that we have an empty file. So let us pull this into a constant. Rf. Sure, there's a constant option on this. There is. So to create our blank, we'll just do file system write file path combine. Do not do that. Path combine root aggregate ID dot toString. And now we need something to actually write to the file, but I don't actually need to write anything. So we'll just do async. No, let's not bother with async. We'll just do x task dot completed task. And that needs a waiting. Right, so now we have a blank file. And we want that to throw an exception, which hopefully it won't do yet. Well, it'll throw a not implemented exception. Yes, so this is what I was saying earlier about this emulating an actual file system. So what we actually need to do is create directory root. Wait. Can you do async constructors? I don't think you can. You can see this exception also tells us what the file system knows about. This means that if it throws a directory not found exception, we can have a look at the error message and see that it's got a directory that differs by case name or such. Right, so we should get a key not found exception, but we get a not implemented, which is what we were expecting. So let's make that work. So in order to do this, we need to read the file, and then if it's empty, throw an exception. Will do. So var events equals fs file system dot read. Now there's a read file lines which returns an IEnumerable. So we give this a path, get an IEnumerable. And as I actually want to make this async so I don't have to keep putting waits in things, I think what I will do is create a private version of this, which is asynchronous. This time it's going to be an async ask of aggregate. Node aggregate internal. Terrible name, but this is only going to be temporary. basically we put the whole function inside that instead. And here we do return load aggregate internal t aggregates aggregate ID dot wait. No, result. And now in here, don't need to do things like that anymore. Wait. Much better. This also means that when I eventually change this API to be asynchronous rather than synchronous, all I have to do is delete this method and rename this one. So now that we've got events, we want to loop through them. Now, is that going to give me an empty enumerable if there are no lines in the file? While there is a line, yield the line. It's yielding. I think I'll just get an empty enumerable back from it. So I need to try and iterate it, and well, you know what? We can just create a list, cast it to an array. Now I want to avoid this in the future because doing that on a large list of items is going to cause issues. Yeah. What I want is like an enumerable peak, because I don't want to iterate the array to the collection twice, but I also want to check if it's got items in it. Something to solve later. So now that we've got events, we can just say if events any is false, then we'll throw the same key not found exception. In fact, at the moment we don't need to do that anyway, because we're only ever iterating it that once. It's being slower than normal. Shut atom. I would shut Chrome, but I'm using it for Twitch chat, so that has to stay open. Mages, in answer to your question, yes to both. It is from a library, but I wrote the library. The NuGet package is called File System, and it comes with an implementation that's in memory for this specific reason. I use it for a lot of work things so that I can keep an eye on, well, so I can test things basically. Right, did that actually run? Ah, what? Should throw a key not found exception, but through an aggregate exception. Because it's async, we're now getting the fun of async methods being wrapped in things, which we can solve in a horrible manner. So we'll catch aggregate exceptions and throw dot inner exception. Yeah, pretty horrible, but once the actual interface is all asynchronous, we won't have to deal with these being aggregate exceptions in the tests. But until we get to that point, we have to do horrible workarounds like that. Great, that now works. So let's go back. Where have my test open files gone? Oh, there they are. Makes no sense. Right, in-memory session tests. So, now let's do one for loading an aggregate. How does this decide what files to show up at any given time? Right, now, this time, we need to write something to our file system that we can then read. So we'll do this. Right, and we need to write these 3 events. Now, we're going to be using JSON serialization, but what I'm thinking is, rather than implement this twice, like once in the tests and then once when we actually want to write to it, we could just use the session's ability to write things to disk as well. But then we're not just testing loading, we're testing saving as well. Right, let's do it like this. JSON convert serialize object. Now we're going to have to serialize each one of these as a separate line and then write a line of them. So is there any formatting on a JSON object by default in JSON.NET? Can't remember. I think we'll extract a method for this in a minute. Anyway, so we'll take our toggle created. Done that in there. Apparently we need an editor, so let's create that as well. Is that just a blank for the time being? Right, now we've done that. So we have some JSON. I want to do stream.writeLine. Using var sw writer equals new stream writer stream. Await writer writes line async that. Yeah, this is definitely going to be extracted into a method. But as I'm going to write quite a lot of things to this, let's do it now. Private void write events, and this actually needs to be an async task. And what do we need? We don't need any of that. We actually just want to params of object by brackets events, and then we shall take that out of the way. And get rid of that. And now just say events.each and as that doesn't have an overload, just do that, get rid of the async. Do that, return task dot completed. That's the weirdest IntelliType help ever. Right, so now we have that. I got rid of that. Where is my writing? That one. So in fact, we just take this whole array and just say await write new write events. Oh, don't need to do that. Get rid of that. Get rid of that. Right, so we now have some setup. So we have our events written. So running this should fail because we don't actually have an implementation to read this yet. Yep, so we get a not implemented exception because we've not implemented it. So let's implement it. That's down here. So we have our events. Well, we have a list of lines anyway. So now we want to do return builder. Now this requires a list of events. I don't really want a list. I don't have to create a list. Alright, should refactor that. So to here we take our events and select E, and now do JSON convert dot deserialize object. as event. Yeah, and then it wants that to be a list, but I don't want that to be a list. That's just not efficient. Do I need to cast it to an aggregate? Yes, yes I do. Right, now we're getting warnings for iterating our collection multiple times, which is correct. Can you check if an enumerable has values without iterating it? I don't want to iterate the first element or not. Thing is, the enumerable has a current move next. You have to hit the move next. Rubbish. Oh well, we'll just cope with those errors for now. Will that work? Ish. There is an error because you've got multiple types of things coming through, so it won't know what classes to deserialize as, I think. So I wouldn't be surprised if this doesn't work. But I do have an idea on how to fix it if it doesn't. Stream was not readable. Probably wouldn't be because we've iterated it twice. It's my file system storage gone. Do this. Oh, I've got to wrap it in brackets. I suppose I could actually move this to here. Why is that an error? Oh, because I've not moved the weight inside the brackets. There we go. Then we'll create it into a list. Despite the fact I don't want a list. And pass it in both places. Now we should only iterate the collection once. Check if it's empty, throw an exception. If it isn't, build the thing. Yeah, it's not perfect, but it'll do. Right, now we're getting null reference exceptions. More interesting. We caught an aggregate exception which doesn't contain an aggregate. An inner exception. That's weird. We'll just do if e dot inner exception is not equal to null. Throw that. Else. Throw. This is doing its best to confuse me. How do you throw a null reference exception on a line that just contains the word throw? Unless the exception is null, which would be weird. Yeah, that's strange. Oh well, let's debug it. Well, let's think about it. Let's stick a breakpoint inside that. Right, so far, so good. What do we have? Right, that's good. Let's see what our events are. A list of nulls, yeah. So that's JSON.NET not being able to handle our deserialization. They're not giving us a nice error. So, as I mentioned, it doesn't know what type it's meant to be serializing. So what we'll do is say var lines equals events select. Yeah, these lines are going to get longer, so just do this. Those off there. Line lines. So we have an event, and we're going to create first some settings. Var JSON settings equals new JSON serializer settings. Now this has a bunch of useful properties in it. The first thing we want to do is make sure our formatting is none. So we want a single line of JSON, not multiple lines. And we want type name handling set to auto, I think is what we want. I can't remember what it is by default. So given an event, we now want to do JSON convert serialize object e JSON settings. Oh, and let's do this as well. Let's get rid of our lines variable. Just put it here. like that. Right. So what this type name handling does is tell JSON that it should include the type name that is being serialized to JSON as a property, so that when you deserialize, that type name can be read and then used to help deserialize the objects. So I'm going to stick a breakpoint on here as well, and so we can check that this is serializing correctly. Once it finishes compiling, run the tests, and hopefully they'll actually work this time. If it ever finishes compiling. Don't recompile it, nothing's changed. Oh. Right. Does this tell me what the value of it is beforehand? No. Well. Oh, and I forgot to set a breakpoint on that anyway. Oh well, we can actually have a look at the file system and see what's in it. The content is a byte array, so we can't view it anyway. Oh well. So this time the line should have a type on it. No, it doesn't. That means we got the wrong type name handling. Objects, perhaps. I thought auto was the right one, but evidently not. Could this be any slower? Well, yes, if I record the streams to the hard drive as well as directly to Twitch, then yes, it gets much slower. I assume we're on a breakpoint. I can't quite tell. There we go. So what we'll do is cheat and have a look at the output of this in the debugger. Ow. We won't cheat and look what's in the debugger. But we can set a breakpoint here, then have a look at it. And there we see we have this extra key here called type, which contains the actual type of the object that we're going to deserialize. Is there a nice way to view all of these? Right, okay. So let's remove these breakpoints. And continue on to here, and now when we deserialize, we should actually get objects back. Or not. I wonder if that means that that bit's failing, or that it's the cast failing. Hopefully we'll be able to run this in the debugger. Newton soft JSON. It's not an unknown identifier, you just IntelliTyped it. Not that I can see the output of this anymore. Yeah, that's broken it. They should be castable to events, they've got their right types in it. So let's do that, and then instead we'll do the cast here, which is much less efficient, but means I will be able to inspect what the output is. Because we might need to pass in JSON settings here as well. Right, that bit we're fine with. That bit we're probably fine with. Right, let's see what we've got. Ah, we have J objects. I don't want J objects. I'm sure that could just return what I was after. I know I've implemented this before as well, so let's cheat and have a look. That's the advantage of having run event sourcing systems quite often. Gotta find the JSON settings. It's probably actually in one of the implementations, ledger.stores.fs. Right, there we go. File store writer. And that inherits file store. Hopefully this has got the line in I'm after. So we deserialize it as an actual object of some form. But we call serializer.serialize, and what is serializer? That's another object. Yeah, time name handling auto. But it definitely passes the settings in. I wonder if that'll do it. Not that we have the settings available here. We do actually, well, we will need this for writing as well, so we'll create them as a variable, as a field in the class. But for the time being, let's do that. I don't know what the type is, and I don't want to, I want it to actually give me something back. Can I do that? Maybe. Let's try one thing at a time. Right. Let's see what we get back now. There we go, we even have the right kinds of objects. So hopefully this will now actually, well, the cast is not necessary anymore, but hopefully our test now passes. Hooray. Right, let's get rid of our... Oh no, we do need that cast, but we'll move the cast back up to the top because I don't want to create a list more times than I have to. And I'm going to commit these and then go and change that so I don't have to create a list. So storage start on file system session. Now, don't like the fact that I need to pass a list into this. It should just be an enumerable. So rather than that, we want an enumerable of event. Now, does that break our tests? No. So if we go to our in-memory session, can that one take an enumerable without breaking things? Oops. Helps if you change the right thing. That doesn't break anymore, but in-memory storage is no longer happy. That's a great tooltip, just a flashing cursor. Right, I'm going to assume that says that it can't convert a list, an IEnumerable to a list or vice versa. So let's just paste that there. Stick that there. Stick that there. Go to that. That can be an IEnumerable. It's your problem. Don't have one. Oh, you do. It's now one of those. Now that's an IEnumerable. Events to load. Happens to be a list in this case, which is fine. But in the case of this one, we are happy with an IEnumerable. Now we don't want to iterate the collection twice still, so we're actually going to still going to iterate it multiple times. We're just going to create an array instead. There's no point it being a list because we're not ever adding items to it. We are, however, needing to iterate it multiple times so we can check if there's events. Part of me wonders what happens if I call a builder with no events. Could I then just check if the aggregate's null and then throw the exception instead? Right, let's see if that still builds. Right, a couple of errors. Just leave from the tests, I imagine. Right, good. And let's run all of the tests because we have just made a fairly significant change to how storage works. Goodness, this is really slow. What is it playing at? Not even maxing out the CPU. It's just slow. of that. So storage, change builders to be func enumerable rather than list. Good, good. Let's go on. So now that we've got that far, we've got an aggregate loaded. Now we need to look into committing. So if we save something and don't call commit, nothing should happen. Which means that we shouldn't need to implement anything for that to pass. Right. Yeah, we can check this by doing file system, file exists, path combine, root. Aggregate id.toString. You know, I probably should actually just introduce that into a variable because I'm going to do that a lot. Should be false. I thought I could just do that. Have shouldly take care of that. Oh well. No, don't navigate. Async. Task. Not entirely sure why that's breaking. I could have sworn there was some task overloads for doing this kind of thing. Oh well. We'll just do that. Exists. Should be false. Now this will fail because we have a not implemented exception here. So let's just remove that. And now run the test. I love these fast feedback loops. Yep, that passes because we don't actually have to do anything to make it pass. This one, however, will need some implementation, which will then break our existing test, potentially. So in this case, we need to read things and then check that the types of the events we got back were correct. So what I'm going to do is find my write events method. That's going to sit at the bottom of the class, as it's a helper. We're going to have one that does the same kind of thing, but for reading. For async task of type. And we're just going to return the types, because I don't think any of the tests are set on what the content of them is. Not from the event store, anyway. No, we only ever check they're the right types. So we're going to say read events. I don't think we need to pass anything into it. Take a copy of our JSON settings. And then we shall do var lines equals await fs read file lines path combine root aggregate ID to string. And then we say lines.select line JSON convert serialize object line JSON settings dot select e. No, don't do that. E dot get type. And as I'm an idiot, that should be an IEnumerable types. Right, so now our test can say var events equals await read events and then this just has that. Right, now this one should fail because we haven't got an implementation of save or commit. Yep, not implemented exception. So let's go and make some implementation. Now we need to implement both save and commit. Save needs to do something, as does commit. So we get the aggregate through here, so we need to take its pending changes and deal with those. So var pending equals aggregate dot get pending changes, or get pending events. Then we want to write them to some kind of in-memory storage, and then clear them off. Now the interesting thing is, if we were to write them to some kind of storage, which would be in memory for the time being, and then call aggregate.clear, and then the code failed before that happened, shouldn't have lost those events off the aggregate, but we're going to, because I have no way of tracking that the aggregate needs to have its pending events cleared off when commit is called. But we don't have a test for that, so I'm not going to bother with it for now, but I think the way to solve it will be we'll have a pending list that will also have taken an action, which will be a pointer to that method. Anyway, so where's that JSON settings? We're going to need these. So let's do this. Let's extract them into a field. In the field initializer, make them static, make them read-only. And I'd rather those be at the top of the class, to be honest. So now that we've got those, we're going to, I think, we can either serialize them before we put them into this pending list, or we can just have a list of objects. Let's see what we do with the in-memory session. So we're grouping them by aggregate. And just storing a list of objects. Yeah, that seems reasonable to do. So let's have underscore pending equals new dictionary of, oh, is my aggregate ID, it is a toggle ID, okay. So toggle ID, then a list of event. So now we say if pending contains key aggregate ID. If it doesn't contain that key, we shall add one. Pending aggregate.id equals new list of events. So now we can say pending dot aggregate ID add range pending. What's your problem? Is that a list of objects? Yep. Cast event. Can't remember why that get pending is a list of objects rather than a list of events. Oh well. And then we shall clear the aggregates pending events collection. Now, shoot, stop that. My goodness, this is being annoying tonight. Right, so now that when we commit, we want to iterate through all of our aggregates and write them out to files. So for each event list, events in, it's actually a pair, isn't it? In pending, var path equals path combine pair, root dot key toString. So now we have the file we're going to write to, and we're going to do file system, and let's say actually var events equals pair dot value select e JSON convert serialize JSON settings. So now we have our list of events. And now we take the file system and do append file path async. Let's not do async, we'll just do stream using our sw equals new stream writer for the stream in question. Events dot for each sw dot write line. and return task.completed. In fact, I think I'm going to call that writer. Not spelled like that though. Has writer got one T or two T's? One. Come on, keyboard shortcuts. Now we do need to await that. Again, I don't have an asynchronous interface yet, so she'll muddle through. And let's rerun all these tests. Right. Cannot find the file. Interesting. But at what line? Test file, I can't find it. Let's check what we're doing here then. Root, key, string, key is set to the aggregate ID. Yeah, well, that should be fine. Definitely got stuff in the pending list. Ah, we have a different toggle ID. Let's do that. And our read method can take in toggle ID. Right, and that should work. I'm getting bored of how long this is taking to compile. Oh, at least it passes. Alright, let's have a look at the diffs. So, file, system, session. Implement event writing. Now, how much of this have we got left? Yeah, quite a bit. But as I'm hungry and I have no food left in my flat and need to actually go out and buy stuff, I'm going to have to leave it here. So, next time we will finish implementing this, and then we shall make the storage interface asynchronous, because I've been talking about doing that for, well, weeks now. So I might as well actually get around to it. As always, the code's available on GitHub, github.com/ponderdom/Crispin, and if you've got any questions, send me a message on Twitter, @ponderdom on there as well. Thanks for watching, and have a good evening.